So, one of the major things to talk about whenever you talk about fatty acids and lipids, and let me rephrase that, when you talk about lipids, is to talk about what are the different major classifications of lipids. So, we kind of gave this background and captured lipids as basically being involved in protection, energy storage, and in communication. Now, your five major classes of lipids are fatty acids, triacylglycerols, glycerophospholipids, sphingolipids, and steroids. We're going to go back over those first four, those fatty acids, triacylglycerols, glycerophospholipids, and sphingolipids. Now, first of all, you've got your fatty acids. These are kind of the base unit. They are an acidic group, a carboxylate, or a carboxyl group up at the top, and then this long alkyl chain. That alkyl chain can have no double bonds, or it can have multiple double bonds. Now, if you have multiple double bonds, those are polyunsaturated fatty acids. A single double bond is a monounsaturated fatty acid. Now, these differ from one another in their common name, but also some of their physical properties. Um, a fatty acid with no double bonds is a saturated fatty acid, whereas an unsaturated fatty acid has at least one double bond. Now, when it comes to those fatty acids, we classify them as either omega fatty acids, which we see here on the left-hand side, or we use a delta numbering scheme, which you see on the right-hand side. Now, the omega are also known as your N fatty acids. So N minus 3 is the same as omega minus 3. So this right here is an example of an omega-3 fatty acid. This is also known as an N minus 3 fatty acid. The omega numbering starts from your terminal or your methyl terminal end of your alkyl chain. Compare that to this delta numbering system where the numbering begins from our carboxyl group as our carbon number 1 and then counting upward from there. So we've got C18:1 delta 9, which we have a double bond begin at carbon number 9, go to carbon number 10. That delta number or that delta 9 indicates the placement of our single double bond. Delta 9, comma 12 indicates that we've got two double bonds. So one of them begins at carbon 9, one of them begins at carbon number 12. Then we've got our delta or our C18:3, delta 9, 12, and 15, those double bonds beginning at carbons 9, 12, and 15. Those numbers, what's very significant about these is that they begin here. Now, this same fatty acid, this one on the far right, this 18:3, delta 9, 12, and 15, this happens to also be an omega minus 3 or an omega-3 fatty acid. This linoleic acid is an omega 6 fatty acid, denoted by this N-6. Now, our next classification of lipids is the triacylglycerols or triglycerides. These are great energy stores, or these are very abundant stores of energy. They are fatty acid triesters of glycerol. So you've got a glycerol backbone, and then you esterify each one of these hydroxyl groups and replace it with a fatty acid. Now, most of these contain two or three different fatty acid residues, which is these R1, R2, and R3 are going to be one to multiple different fatty acid groups. Okay, now after that, those glycerophospholipids or those triacylglycerols are great kind of building blocks that we can use to look at and compare them to molecules known as glycerophospholipids. One common element to them is they have this glycerol backbone. Okay, so they've got that three-carbon glycerol backbone. Now, glycerophospholipid is going to have two of those esterified groups with a alkyl chain on the end of them, but the third carbon is going to have a phosphate. And on that phosphate, there's going to be a group that, in this case, we're just going to label as X. Now, that X can be any number of things. Now, the big divider between triacylglycerols and glycerophospholipids is that triacylglycerols are nonpolar lipids, whereas glycerophospholipids, by the presence of this phosphate group and this head group, we've got a polar end to it. So these are polar lipids, and they are major parts of bilayers. Now, like I said, that X, here it's denoted in red, that X can be replaced by any one of these different things. Now, if you look at, well, it could be an H. That would be water. Okay, so that makes the compound known as phosphatidic acid. It could be replaced by, well, this is a little bit bulkier, and there's a charge group to it. That makes a molecule known as phosphatidylcholine. Oh, but then we put a six-membered ring on it. That makes something known as phosphatidylinositol. So that X can vary quite a bit. And then it could get as large as this thing right here, phosphatidylglycerol. This makes something known as diphosphatidylglycerol or cardiolipin. Now, what's significant about this is that at the other end of it, the other two carbons of this glycerol backbone are these two esterified fatty acids. Well, this is going to be displayed on the outer side of the membrane. The R groups here, R2 and R1, those are going to be found on the interior of a lipid bilayer. Now, that is one of or those compounds are used for communication. So if we go back and talk about the different things that lipids are involved in, energy. Okay, we've got our triacylglycerols, which preserve a lot of energy. We've got major parts of bilayers, so protection, glycerophospholipids do that, and communication, glycerophospholipids do that as well. At their heart, or at the heart of them, we have our fatty acids. Now, the other place that we can go that whenever we talk about polar and non-polar lipids is to, again, I want to bring your attention to this three carbon backbone right here and right here, respectively. And I want to draw your attention to this right here. This is another three carbon backbone. The difference is that we've got a phosphate group, just like a glycerophospholipid, and that's got a head group, so that's a polar group. But then at the other two carbons that make up this backbone, we've got an alkyl chain. It's not an esterified alkyl chain, so it's not a fatty acid, but then we've got this amine that has replaced an alcohol, and that amine is where we're going to have a fatty acid. So the point of all this is a compound known as a sphingomyelin. This is an example of a sphingolipid. Now, these are also major parts of membranes. Now, a sphingomyelin, specifically this compound known as sphingomyelin, the head group, or phosphocholine or phosphatidylethanolamine, found right here, are one of the two options. Cerebrosides are examples of sphingolipids that have a head group where the head group is a single sugar like glucose or galactose. Now, the significant point of this is whenever you start putting sugars here, this is another mechanism by which these lipids can be used for communication. Okay, so if we kind of go back and track through what we've talked about, our different classifications. Fatty acids, we looked at the nomenclature of those. Triacylglycerols, we looked at the glycerol backbone. Glycerophospholipids, the glycerol backbone plus that polar head group. Sphingolipids, glycerol backbone, basically a glycerol backbone or three carbon backbone. Then we got a phosphate plus a head group, a amine, and then an alkyl chain coming off of it. Now, these are all examples, or these we kind of got to how they can all be involved in protection. So think about your glycerophospholipids and sphingolipids as being major parts of membranes. So they're for your protection, they're for the cell's protection. Triacylglycerols and fatty acids are going to be used for energy. And then those glycerophospholipids and sphingolipids and cerebrosides can be used in communication. All right. Well, that should capture, kind of summarize up the four functions or the first four functions of lipids.